Welcome back to the deep dive. If you feel like the pace of AI innovation has been dizzying over the last couple of years, well, strap in.
That's putting it mildly.
Right. Our source material today, it's a massive stack centered around the CES 2026 keynotes. It all suggests we're operating at a fundamentally different speed now.
And that speed, it requires a whole new foundation. I mean, both in terms of the hardware and the architecture.
So that's our mission for this deep dive.
Exactly. We're going to try and isolate the actionable metrics and, some of the surprisingly specific technical announcements that are building the infrastructure for what everyone's calling AI everywhere and for everyone.
And we're tracking that power all the way from the huge scale of the cloud down to the device in your hand.
The scale is really the first thing that hits you. It's almost hard to grasp.
It is. Let's look at the growth curve. I mean, think back to ChatGPT's launch. Reaching 1 million users was seen as this, historic acceleration.
A huge deal. But today, the sources are confirming that AI now has over 1 billion active users.
1 billion. And that isn't even the ceiling.
Not even close. The projections that were shared are pushing toward 5 billion active users. That's a growth trajectory that, well, it mirrors the explosive adoption of the internet and cell phones combined.
Okay, so if you suddenly have billions of people using AI every single day, what does that do to the world's computing capacity?
It buckles. It has to. The demand for raw compute infrastructure has grown at an almost unbelievable rate.
What are the numbers?
So we've seen the global demand surge from roughly 1 zettaflop in 2022 to over 100 zettaflops in 2025.
Wait, say that again. 1 to 100.
1 to 100. That's a 100-fold increase in just 3 years.
100 times the global compute capacity needed in 3 years.
Yeah.
That's an almost unimaginable amount of infrastructure to build.
And it's still not enough. That's the crazy part. The sources are all telling us we still don't have enough to unlock AI's full potential.
So what's the goal then?
This is the jaw-dropping number they announced. The forward-looking goal is to increase the world's available compute capacity another 100 times over the next 5 years.
Another 100 times.
Yep, aiming for more than 10 yottaflops.
Okay, let's just pause there for a second. Because those terms, zettaflop, yottaflop, they start sounding like something out of science fiction. Can you give us a sense of just how big 10 yottaflops really is?
I mean, it's the definition of scale. A yottaflop is 1 followed by 24 zeros.
24. Wow.
So when we talk about 10 yottaflops, what we're really aiming for is 10,000 times more compute capacity than the entire world had available just back in 2022.
10,000 times. This isn't a gradual ramp up. It's an absolute mobilization.
Exactly. We are demanding exponential hardware jumps just to support the exponential user adoption. You can't just iterate on old designs.
Which brings us to the new hardware, the foundation in the cloud. We're talking about the Instinct MI455 accelerators and this Helios platform.
Right. The MI455 is basically the brain of this whole jump. It's using cutting-edge 2-nanometer and 3-nanometer fabrication processes. It packs 320 billion transistors.
320 billion. And for context, how does that compare to the last generation?
That's about 70% more transistors than the MI355. And this generational leap, it promises up to 10 times the performance across a really wide range of AI models.
That's the microscale. But when we talk about the physical reality, building a Yodascale data center, the numbers get just immense.
Yeah.
The Helios rack system is physically enormous.
It is. It's a double-wide design, which means, twice the footprint, and it's built to the Open Compute Project standard.
And the OCP standard, that's important because it's open, right? Not proprietary.
Exactly. It's designed for massive, easy-to-scale deployment, no vendor lock-in, but the sheer mass.
Yeah.
One of these Helios racks weighs nearly 7,000 pounds.
7,000 pounds. That sounds less like a server rack and more like a small elephant.
Or a couple compact cars.
Right. Are we building server farms? Or are these highly optimized power plants? The physical constraints here are just intense.
They absolutely are, and the demand is being driven by the next wave of AI applications. The sources really stress the deep partnerships here, especially with OpenAI. Greg Rockman was quoted describing his constant need for more compute as a broken record.
He had a great explanation for why this need is basically infinite. He talked about the shift to agentic workflows.
Mm-hmm. It's not about asking one question anymore.
No. It's about having a whole fleet of specialized AI agents working for you, searching, drafting, executing tasks for minutes or hours or even days, all for a single outcome.
And Brockman revision, it's that we'll eventually need a GPU running in the background for every single person in the world.
That's such a bold projection.
Yeah.
We have to wonder, is that growth rate sustainable? Or is it pure marketing?
Well, the answer, if you look at the next-gen applications, is that this kind of compute is required for what's coming next.
Case in point, Luma AI. Their mission isn't just text or images. It's to model and generate entire worlds.
Yeah, by combining audio, video, language, image data, everything. They showcased their Ray 3 model, which they're calling the world's first reasoning video model that can generate in full 4K and HDR.
The business insight there felt crucial. Luma AI chose to run 60% of their inference workloads on these cards, and they said they were heavily prioritizing total cost of ownership.
TCO. That TCO metric is the silent driver of this whole Yodascale push, isn't it?
It has to be, because generating a single 4K HDR world must eat up tokens thousands of times faster than asking ChatGPT a simple question. If you're generating worlds, cost efficiency is everything.
Precisely. If the cost of the compute is prohibitive, the application just never scales. TCO is the difference between a cool prototype and a global industry.
Okay, so that's the cloud infrastructure sorted. But how does this immense power actually get into the end user's hands? We need to pivot from the 7,000-pound racks to the device in your backpack, the AI PC.
Right. And we're transitioning from the cloud delivering intelligence to the device becoming an active partner, one that learns and adapts to you locally.
Which means huge privacy and efficiency improvements.
Yeah.
This is the AI PC revolution we keep hearing about.
And the core hardware innovation here is the new Ryzen AI 400 series processors. They integrate several key components, Zen 5 CPU cores, RDNA 3.5 GPU cores, and they specialized XDNA 2 NPU.
The NPU, the neural processing unit, that's the key part, right?
That's the crucial part. It's a dedicated, hyper-efficient AI engine. It delivers up to 60 TOPS of AI compute.
And TOPS is tera operations per second.
Right, which means it can run complex models right on your laptop without draining massive power from the CPU or the GPU, which is obviously critical for battery life.
And this new architecture is rolling out in over 120 different PCs this year. But, the hardware is just the vehicle.
Absolutely. The software is where it gets really interesting. We saw a great example with Liquid AI. They're building these liquid foundation models. It's a novel architecture that is not a transformer.
And they're optimized for on-device efficiency. They showed off their LFM 2.5 model. It's tiny, only 1.2 billion parameters.
Which is nothing compared to the big cloud model.
Exactly. Yet they claim it delivers instruction-following capabilities better than much larger models like DeepSeek or Gemini Pro, but running entirely on the laptop. That's a massive step change.
It really is, and it raises the important question, why does local compute matter so much if the cloud is getting so powerful?
Well, Liquid AI defined 3 key value props: privacy, speed, and continuity.
Because the AI is always on and local.
Right. It enables these proactive agents. They gave an example of an agent noticing a calendar notification, seeing you're in deep focus work, and then proactively offering to join a sales meeting for you, give you a summary later.
That shift from a reactive assistant to a true proactive partner operating locally for guaranteed privacy, that's huge.
And for the developers who want to build those agents, they announced the ultimate platform, the AMD Ryzen AI Halo.
Which they described as the smallest AI development system in the world.
It's essentially a pocket-sized workstation. It can run models with up to 200 billion parameters locally, supported by 128 gigs of unified memory. That is just an insane amount of power in your hand.
So now let's transition to where all this compute, both cloud and local, is having its deepest, most meaningful impact, the physical world, starting with healthcare.
The anecdotes shared by OpenAI's Greg Brockman were genuinely powerful. They show immediate personal relevance.
Yeah, really do.
He talked about ChatGPT helping a coworker diagnose a life-threatening blood clot that doctors had initially just written off as a pulled muscle.
And then there was the other one, where it warned a CEO against an antibiotic that could have dangerously re-triggered an existing condition.
It's AI as a life-saving safety net. But the industry transformation goes even deeper. Take a company like Apps AI.
Right. They're using generative AI to precision engineer entirely new drugs from scratch.
The scale is immense. They can screen over 1 million potential drugs in a single day. And their focus areas are these major unmet needs.
Everything from curing common baldness, androgenic alopecia, to developing a therapy for endometriosis.
Which affects 1 in 10 women globally. It's a huge deal.
And it demonstrates this new capability of precision engineering in biology. It's radically changing the drug pipeline. AstraZeneca confirmed it.
What do they say?
They noted their use of generative AI is reducing the number of experiments, and that's resulting in a 50% faster delivery of candidate drugs to clinical trials. It's literally accelerating the scientific method itself.
That speed is a theme everywhere. Let's move from biology to spatial intelligence and world creation. Dr. Fei Li of World Labs, she anchored her presentation on the idea that humans are fundamentally spatially intelligent.
Connecting perception with action. So World Labs developed this marble model. It learns 3D and 4D structure directly from input data, and here's the breakthrough,
It can take just a handful of images or even a single one.
and generate rich, permanent, navigable 3D worlds.
Think about that. What used to take a professional 3D artist months to model can now be done in minutes.
We saw those impressive demos, right? The Hobbit world, the remodeling of the AMD office. The speed is what makes it feel instantly
The
reactive.
physical world impact also extends to robotics. Generative Bionics showed their Gene 1 humanoid robot.
Its design is inspired by biomechanics, so it walks by, subtly falling forward, maintaining balance dynamically. It's very human-like.
But the key innovation wasn't just the walking. It was the distributed tactile skin across its entire body.
So the robot can feel pressure and contact.
Exactly, which enables far safer human-robot collaboration in places like factories or even hospitals. They're planning to manufacture the first commercial unit by the end of 2026.
And finally, we saw AI pushing boundaries in the ultimate edge environment space.
Right, Blue Origin. They talked about their mission for lunar permanence and moving heavy industry off Earth.
John Kears emphasized that their flight computers have to be deterministic, reliable, and, resilient to deep space constraints. Mass, power, radiation.
So AI is serving as an astronaut co-pilot, identifying landing sites and hazards in real time.
But the most fascinating example of edge AI was the plan to use the Mark 1 lander on the far side of the moon for radio astronomy.
Because it's shielded from Earth's radio frequency noise over there.
Precisely. And they'll use AI on the edge to optimize deep exploration and find the perfect spot to land the next vehicle. It's incredible.
All of this, though, all this immense compute, it requires a political and strategic mobilization to support it.
Michael Katzios, the former U.S. CTO, introduced what he called the Genesis mission. He described it as a moonshot program,
He put it on the scale of the Apollo mission or the Manhattan Project.
which is a huge statement. The goal is to accelerate the convergence of AI, supercomputing, and quantum computing to, and this is a quote, double the productivity and impact of American science within a decade.
They laid out specific U.S. strategic priorities. First, removing regulatory barriers. Second, getting the infrastructure and energy production right.
And they specifically mentioned advanced nuclear reactors as key to powering these new data centers.
And third, AI diplomacy, exporting American technologies globally.
The emphasis on talent development was equally strong. They highlighted the Presidential AI Challenge and the AI Education Pledge.
And we saw that amazing real-world outcome with the Hack Club high school students. They built an AI robot barista team arm mender using a Ryzen AI laptop.
What's truly inspiring there is that these students had no prior AI training, none.
Yet they were able to quickly build a complex vision language model because the platforms and software are becoming so much more accessible.
And that really underscores the $150 million commitment to getting AI into more classrooms and democratizing access.
So, if we try to synthesize everything we've covered, what does this deep dive really mean for you, the listener?
Well, we've seen the sheer physics-defying scale of the Yodascale goal. We've seen the physical infrastructure of the 7,000-pound Helios racks and the personal compute platform of the Ryzen AI Halo.
The central unifying idea seems to be that AI is just fundamentally different from previous tech waves. It's driving compute demand faster than anything we've ever experienced.
And the co-innovation is happening across the entire stack. You need open software to work with this new specialized hardware.
Which is creating three essential platforms for the future.
Right, the powerful cloud, the proactive local PC, and these resilient embedded systems in robots and spacecraft.
For you, the listener, the key takeaway isn't really the transistor count. It's the application of that power.
Exactly. And if we look at the ultimate vision laid out by the experts in healthcare like AppSAI's CEO, the final goal is to shift from reactive, sick care to preventative, and ultimately to regenerative biology and medicine, where aging no longer is linear.
Think about that. All this massive mobilization of technological power, all these yottaflops of computing.
Are ultimately creating a world where AI should help us predict sickness, prevent sickness, and personalize treatments to radically extend our lives. That's the immediate personal relevance of building a world that's 10,000 times more powerful than the one we had just a few years ago.